Of course, in the lab, we don't have a huge fractionating column. Instead, we have a tiny fractionating column. So what is going on here? Well, this is a little simpler. They have just two things mixed together in here. Heptane and octane. So the C7 and the C8, there they are, mixed together as a liquid in the bottom. Where are we putting the heat? Well, this is what is heating it. It's called a mantle. It wraps around the base of this nice round bottom flask and heats it wherever it's touching it. So the heat is being applied here. But where's the thermometer? Well, the thermometer is all the way up here with the part that takes the temperature right where this arm comes out of the glassware. So once something is vaporized, then it's going to be in the fractionating column. But as it rises, it's getting further and further away from the heat, and it's getting cooler and cooler. So by the time you get up here, the only thing that is still vapor is going to be the heptane, not the heavier octane, which has more intermolecular forces holding it together. That way, if we hold this at the right temperature, the temperature where the heptane would like to boil, we can get it so that only heptane comes out over here. And then what is this tubing? What is this about? Oh, this is running water through here. This is a double-walled thing. So the outer wall is getting water put into it to cool the vapor. If the vapor cools, then it turns into a liquid and it drops down into here, and you can collect just the heptane and leave the octane behind because it's the heavier one that boils at a higher temperature. If you were watching this, what you would see is that you were collecting some liquid. And while you were collecting the liquid, originally there would be no liquid. As the thing heated up, you would start to see some liquid come over. The temperature would stabilize in the thermometer at the 98 degrees Celsius for the heptane, and it would stay at that temperature. The volume that you were getting to come over to the new flask would continue to increase until you had gotten all of the heptane. Then all of a sudden, the temperature is going to start to go up again without any more liquid coming over. Now, if you're really trying to keep these two separate, this is when you unplug everything and take the second vial away. But if you've never done it before, you might be confused and you might allow it to increase temperature. Ultimately, it gets up to the boiling point of the octane, and then the octane starts coming over and putting more liquid. And at the end, you would say, oops, I did not mean to do that, because now the first flask is completely empty, the second flask is completely full, and I just have the same stuff. And I didn't separate anything. I could argue for switching the axes, because what really here is the independent variable? Well, it's the temperature that's the independent variable, because I'm controlling the heat. The volume is occurring as a result of the heat. But this is typically how people have graphed it in the past, so you need to know that that is what that would mean. What we have here, we have a red line and a blue line. This red one is an actual straight line. The blue line is a curve. We have a very confusing thing down here. We have two different sets of markings on the x-axis. We have 0 to 100, and then we have 100 down to 0. This is supposed to mean the percentage of octane and heptane. It can only, it can be a 50-50 mixture. At this end, it would be all octane and no heptane. At this end, it would be no octane and all heptane. So this red line is supposed to be a straight line from the boiling temperature of heptane to the boiling temperature of octane. And the blue is a curve. That's because the solution doesn't always boil the same way that you would expect from the vapor. Remember, the blue is for the solution and the red is for the vapor. So what we have at 0.1, right here, we'd have a 50-50 solution of this stuff. We would find that it would start boiling. This would be the temperature down in the first flask, not up here where we're measuring it. It's down in this flask. So it's boiling in the flask at a higher temperature than the boiling temperature of heptane. When it boils, it turns into a vapor. The vapor is going to have a composition that favors more heptane than octane, because the heptane is the lighter one that has a lower boiling point. So the vapor itself favors heptane over octane. Well, it goes up the tube a little ways, and now it's at a cooler temperature, so it condenses, and it's forming on the walls. But those are still warm, and so they can, if you want to say evaporate rather than boil, it's okay to think of it that way. And it will turn into the vapor again. Again, favoring more of the lighter heptane than the octane. So you see, I'm getting to where I'm going this way, which means I'm getting more heptane. So more heptane, less octane. And I keep making this stair-step thing so that when I get up to the top, I'm at the boiling temperature, only pure heptane. And I've left all the octane behind, and then I can separate them.